All right, so I just finished a video about trig identities and how to simplify things. And at the end of the video, I left a couple of problems out there for you to do on your own, and I just gave you the answers. So I thought I'd do just a quick one where I actually work these things out and show you why they are what they were. So the first one here, sine x times cosecant minus sine. We can use the trick here of writing everything in terms of sine or cosine that we can. So we can take this, sine x times 1 over sine x minus sine x, and then distribute the sine x through there. So sine x times 1 over sine x is just 1. Sine x times negative sine x, sine squared x. And 1 minus sine squared x, we should be starting to get familiar with Pythagorean identities, so we know this is equal to cosine squared x. And that is your answer. So that's the first one here. The second one, kind of the same deal, and there's a couple ways we can do this one. I think the easiest thing to do is recognize this as cosine squared x. So we have, and then if we write the secant squared with our reciprocal, so we have 1 over cosine squared x times cosine squared x, and well, that's just equal to 1. And that's all there is to it. There's a longer way to do that one, but why do we want a longer way when we have short ways? So the next one here, secant x times sine over tangent. This one, you have to deal with some fractions on this one. If we write secant as 1 over cosine, that's fine. And then sine x, and we can write tangent using the quotient identity as sine over cosine. Leave the first guy alone for a second, so 1 over cosine x times, then we got sine x, doing the old keep, change, flip thing from middle school, times cosine x over sine x, and we can put him over 1 if we want to, and look what happens. Cosines cancel out, sines cancel out, so that's why this also equals plain old 1. For the next one over here, I'm going to slide these things down a little bit because I might need us a little bit more room on this one to kind of get this guy knocked out. So cosine squared over 1 minus sine x. This is our couple ways you can do this one too. We can multiply by the fancy one. I think that way is a little bit longer, honestly. So I'm going to use a trick that you might not see right off the bat, but it's something that might be useful. So I'm going to use this, the cosine squared, and I'm going to go back to my Pythagorean identities, and I'm going to see, oh, well, that's equal to 1 minus sine squared. So I'm going to write it like that. So I've got 1 minus sine squared x over 1 minus sine x. Now, for heaven's sakes, please don't tell me something cancels out there, because it doesn't. But what we can do, we can use the factoring trick that we talked about. So if I factor the top like a quadratic, this becomes 1 minus sine x times 1 plus sine x all over 1 minus sine x. Now something cancels out. Boom and boom. So this becomes 1 plus sine x. And that is the simplified version of cosine squared over 1 minus sine x. There is another way to do that by multiplying by the fancy one that I called it, but I think that's a couple extra steps and a little bit harder to get to. But it would certainly work. You would still get 1 plus sine x as a result there. And then my last two, cotangent squared minus cotangent squared minus cosine squared. First thing I see here is a GCF. So it's cotangent squared and then 1 minus cosine squared. Factor the cotangent squared out. And then I'm going to do two things at once here. So I know cotangent squared is equal to cosine squared over sine squared. And I know 1 minus cosine squared is equal to sine squared. And if I want to be precise about it, I can write that over 1. And again, my sine squareds cancel out. So what am I left with? Cosine squared x. And that is your simplified version of that big thing on top. And then the last one's kind of a doozy. A couple ways you can go about this one too. Let's see, which way is the shorter way? I'll do the shorter way. So the first thing I'm going to do is say, well, how about if I just combine the fractions? So if I want to combine the fractions, I need a common denominator. So I'll multiply this by tangent x over tangent x. And if I do that, what do I have? I've got tangent squared x over tangent x minus secant squared over tangent squared, or tangent x. So I've got my common denominator. I can put them together, which means I have tangent squared x minus secant squared x all over tangent x. Well, if you remember your Pythagorean identities again, I know I sound like a broken record, but they're going to be all over the place. Tangent squared minus secant squared is equal to -1. So I've got -1 over tangent x. And if I want to write that without a fraction, I can actually write that as negative cotangent x. There's another way you can do it too. If you start off by writing everything in the original one, just with sines and cosines, and then kind of go on from there, that'll also give you negative cotangent x, but there is a few extra steps there. Extra steps are not bad. You know, you see what you see, but as long as you're kind of following the rules and using identities, then you're always going to get the same answer there. Okay, so again, just wanted to run through, I had these same 6 problems on my previous video, but that is how you actually work them out. And I will link to that previous video. You should see something on your screen right about now. On that previous video where I kind of introduced all of those different identities and the techniques to do that. And also, don't forget, if you want to see some more videos on pre-calculus and trigonometry, don't forget to subscribe. And I appreciate you watching again, and we will see you next time. Have a good day.